Siri.
Morning class. Oh my gosh. That should be alright. Okay, this is week 9 and your midterm test fall on week 12. Week 9, week 10 is a holiday. Week 11, we have one more week of lecture, then your midterm test. Okay, we have, let's see. Oh, sorry. This one. Okay, we are going to cover chapter 6 today and then chapter 7 next week. Okay, next week chapter 7 because your midterm test will cover from chapter 1 to chapter 7. Then after week 12, we have week 13, one more lecture, which will cover chapter 8, 9, and 10. 8, 9, 10. Week 13. You don't have to come here. You can just stay at home because these 3 chapters will be something like extra knowledge to you all regarding research. And then week 14's lecture will be replaced. Week 14 lecture will be replaced by week 14 Monday's webinar. Week 14 Monday, we are going to conduct one webinar, 1 hour, 8 to 9 o'clock. You attend that webinar. It's equivalent to attend your lifelong learning. At the same time, attend your week 14's class. So attendance will be taken based on your webinar's attendance and participation. Okay. All right. So let's cover chapter 6 because you need this in your exam. Wow. Not updating real time. Okay, let's quickly go through this chapter because this is the most confusing chapter. I hope you all are clear by now regarding the data analysis especially and the interpretation of the result. If you are given a case study, make sure you know all the data analysis method shown in this chapter. The Cronbach alpha is used to test reliability of your questionnaire item. T-test, we have one sample t-test, independent sample t-test, 2 sample t-tests. Okay, and then correlation, you are doing this in your assignment to test whether there is any relationship between 2 variables. Regression, we come up with a formula to predict your y equals to or x equals to or whatever formula, your dependent variable. Your dependent variable can be predicted based on your independent variable in this regression. And last week, we have also covered chi-square, in which chi-square is used particularly on the categorical variables. Categorical means it's not continuous, numeric. It's category. Like for example, you have cost. What is your cost? Then we have category of RSF, RSD, RST. These are the different category. What is your age? Age. So you write down your age, 21, 19, 18. This is continuous numeric. Bravo, not category. So chi-square is used on categorical analysis. Now today we're going to look at the ANOVA, analysis of ANOVA. And there are two different analyses of ANOVA. First is one-way ANOVA, and the other one is called two-way ANOVA. Okay, variance means difference. Variance means difference. We want to see the variance, variability, variance, any difference, any difference. Any experiment that has more than two conditions must be analyzed by ANOVA, analysis of the variance between the groups and within the groups. What does it mean by within condition and between condition? Variability within groups means if, let's say, I want to test whether there is any difference among you all. We have, in this research method, we have RST, we have RIT, RSF, RDS, RSD. We have different kinds of groups, right? So I want to compare whether all these groups actually perform differently in the exam. Exam will be the easiest way to test whether you have any difference or not. And there are two kinds of difference that I can test. The first is within the group or within condition. Within RSF, among RSF students themselves, do they have a lot? Do they have big difference among themselves? Only within the RSF themselves. Okay, and then within the RSD themselves, all the students from RSD, I can test whether there is any difference among themselves only. We don't compare with other. We don't compare with other program, right? We don't compare with other program. We compare within the same program. That is called within groups. Variation within the groups, within condition. Okay. Now after that, you are going to compare also between groups, different groups. So I'm going to take the difference between RSD group performance and RSF group's performance, and compare with RIT group's performance, compare with each other. So that's called variability between the groups or between conditions. And after that, analysis of variance is based on this formula. Between condition variance or variability divided by within condition variability. Let me give you an example. Between condition variability and within condition variability, I give you one, I don't want to give you, okay, academic performance, okay. Academic performance, right? We're going to compare. I think academic performance is a little bit sensitive. Later on, you say, wow, I say RSF is better than the other group, then you're all not happy with it. Okay, let's say height. Okay, and we have RST student, RSF student, RDS student, RIT student, right? Okay, let's just compare these two groups. RSD student, who is the tallest that you know among yourself? Can you report the height? The tallest height that you have in RSD group. Can you report? RSD. What is the tallest in RSD? Okay, who is the tallest? Can you please report in RSD in your own group? Yeah, just give me the number. RSD. Who is RSD? Can you give me the tallest? Who is the tallest in your group? What is his height? No idea. Wenxin, are you here? It's a good time to check whether you are here. Oh, absent. Okay. Absent, yeah? Please take note of that. How about your Jingshen? Jingwen. What is his height? 18 plus. 180. Is it? Wee9 185. 185. Okay. RSF. Who is the tallest anyone from RSF? What is the height? Are you sure? Kaiser, who is 210? I never realized there is a 210. I only know there is one 190. Kaiser, who are you? 193. See, I know there is someone 193, if I'm not mistaken. From RSW, sorry, RSW. You have changed, yeah, RSW. Okay, let's say we have 121. I don't think 210，我没有遇到210的，肯定的。190有，我知道有一个他坐下来不像190，他站起来是190。我讲你从哪里来的，我还记得那个人，但我不记得他的样子。Okay, 185. Okay, now let's test. What is the difference within and what is the difference between? Okay, now within, the difference, the variance within, right? Let me show you this. Between and within. Within condition. So we have within. Within means within your own groups. Within condition, what is the variance? Variability. This is 5 cm. And this is 8 cm, right? The variance. The variance within is 5 cm, but the variance within groups here is 8 cm. Okay, how about between? The variance between group. So you merge it and say between groups is 3 cm difference, right? 3 cm difference. Okay, let's state an average of this within group. Of this. Average of within group variance is 6.5. So if you take this formula, between condition divided by within. So between, so your ANOVA, between is equals to this one, divided by within, 0.46. The value of ANOVA F is 0.46. 0.46, it's not significant. It must be more than 1. F must be more than 1. Which means that this difference, these two difference is not so much. Okay, let's do something. Let's say if we have 210, then we have 0. We think okay, between the condition means this one. Between the condition, it should be this one minus, so it is 3, and within variance is 6.5. So within variance is even higher than between all. Means the variance, the difference within this group is even higher than this one, right? Between the group. So it's not significant. Within the variance within the group is even higher than the variance between these two groups. If let's say we have everybody almost the same height, like 195, 192, everybody almost the same height, right? If everybody almost the same height, 182, and then this one is 3. Can you see the difference? The ANOVA, it will go up to more than 1.0, which also means that the difference between these two groups is significant, because it is very consistently that everybody in RSD is 180 plus plus, whereas RSW is very consistently 190 plus plus. When your within variation is very consistent, then only you can see the difference between two groups. Then only you'll be able to see the difference between two groups. But if your variation, if this group has very, very much difference, like one person is 150, then within the group itself is not consistent, then definitely your F will be not significant, lesser than 1.0. That's the condition between and within the within groups. And therefore, you must find someone that is consistent within the groups in order to compare with each other. Right, there are other values that you can actually interpret from the table, which look like this. This is how it looks like, the analysis of ANOVA. No, this is the analysis of ANOVA. You will see this word ANOVA, and you will see F and SIG. F must be larger than 1, and SIG must be smaller than 0.05 in order to prove that there is a difference between different groups. Let's take a look at one example. Okay, other definitions: sum of square, measure of your variation in the data, degree of freedom, quantity that depends on the number of groups. Degree of freedom means you have how many groups, and then mean square, sum of square divided by numbers of degree of, okay, all this you can try to figure out from the internet, but the most important indicator will be the F ratio, this one, F ratio, which must be larger than 1.0 in order to show experimental effects. Yes. Who raised your hand? Or you accidentally raised your hand? Okay, let's continue. Let's say we want to carry out an experiment to find out whether there is any significant difference in sleeping hours among the students of different groups. So RSF, RST, REI, do they have any difference in sleeping? Because I suspect that RSF students will have more workload and therefore they will sleep less. Are you RSF? See, RSF. 4-pointer, only sleep 5 hours. Last night 4 hours. When is your lab? Later on. Very stressful. Yeah, become very stressful also. Okay. Independent variable and dependent variable. So dependent variable is the hours of sleep. We want to test whether the hour of sleep is depending on the program that you are involved. So please ask your junior, don't join RSF. RSW, right? Change their name already because RSW. Let me change it because this will be used by about 500 students next semester. So I have to give them this slide. I have to edit the slide for them. Oh, because this is, where is my mouse? Okay, never mind. Okay, so we're going to compare. We're going to compare between RSW, RST, and REI, the hour of sleep. So we have three groups of people with the hour of sleep. So I should update here, right? 5, 5, 5, 5, and so on and so forth. And then the null hypothesis tells us that there is no difference between these three groups of people. The sleeping hour between these three groups of people. There is no, this is null hypothesis, which also means that what is the alternative hypothesis then? If this is a null hypothesis, what is the alternative hypothesis? There's a significant difference in sleeping hours. Yes, among all these three programs. Correct. Make sure you know how to construct this as well because they are going to have many options now, alternative, blah, 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 blah. Sorry, 8 options. I screen through the question again. 8. Because the final exam paper has been sent for printing. So they asked us to glance through if there's any issue, help to identify. Then I found there's one question with it, 1, 2, 3, 4, 5, 6, 7, 8. 8 option. Blah 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 blah. A lot of things. Good luck. Okay, let's continue. Now let's say this is the result of the experiment of this, the number of sleeping hour, and the ANOVA test tell us that F is lesser than 1, SIG larger than 0.05, and therefore we accept null hypothesis. Reject hypothesis. Reject hypothesis because, okay, because within variation is larger than between variation. Within variation is larger than between variation. So no difference. Okay. Now, one-way ANOVA is used when you have independent variable with the option of the groups more than 2 levels, more than 2 categories. If you only have male and female, for example, if you are testing whether there is any difference between the sleep of hour between male and female, 2 groups only, you can use chi-square. You don't have to use this. Analysis of variance ANOVA is because you have more than 2 levels. More than 2, yeah? Not 2, more than 2. Then you use ANOVA test. Okay, let's continue. Employees in casual clothing will show higher job performance than employees in business clothing. Identify which data analysis method is the most appropriate for the above hypothesis. This is an example of your midterm test. Okay, employee in casual clothing. So job performance, what is job performance versus clothing, right? Then you have to identify first. What is the DV? Job performance, yeah? And then what is the IV? Clothing. So let's do something like this. Perhaps this can help you to answer in your midterm test. Whenever you get this kind of case study, because there are many this kind of case study in your midterm test, they'll give you a lot of case study. So you have to identify what is a DV, quickly identify your DV is performance, right? And then your IV is clothing. Can you identify the DV performance? Should it be numeric or categorical? Could be numerical, right? What about clothing? Definitely categorical. And how many category? Only two category. For which one you can use? Okay, casual and business clothing. Yeah. So which analysis method is the most appropriate for the above and hypothesis? Okay, let's go back here. Investigate if two categorical variables are related, right? Right? This is the category. This is also category. So use chi-square. Relationship status and the program. But two are categorical, then you use chi-square. Okay, sorry, I think I made a mistake just now. This one, independent variable, we have another one, which is, um, yeah. Let me show you another one. Perhaps this will give you clearer picture, which is from your practical actually. Your practical PSPP slide. Shall I copy and paste this? Oh, they have deleted. Let me retrieve back another slide, which is the earlier on. From your practical slide, yeah, practical, this one. Because they have missed out another um, two-way ANOVA. Let me share the whole screen. Let me share with you. This is the past year PSPP notes. So they have converted this into the lecture because they want us to teach in the lecture instead of in the lab. Okay, one way we have one-way ANOVA and we have also two-way ANOVA. But I think they have missed out the two-way ANOVA. Two-way ANOVA here. Okay, two-way ANOVA, we have another analysis in which you are going to analyze more than um, more than two independent variable. You have more than 2 independent variable. One-way ANOVA, you have only one independent variable, which is the group, right? The program group. But what if I want to test? Is there any difference between this one? Is there any difference between the hours of sleep? If I want to test between program plus another factor, if I have another factor, maybe your gender. So you have male and female. If I have 2 independent variable in this case, then you should use two-way ANOVA. If you have only one IV, then you use one-way ANOVA. Got it? Okay, so let me see. Your slide, two-way ANOVA. Your slide got two-way ANOVA. But there is no explanation of two-way ANOVA. So in the lab, in next week lab, we will start to look at all the analysis again in the PSPP. So by that time, you will have your second time of revision in the lab. Okay, the one-way and two-way ANOVA. Okay, so just to let you know lah, that's the only thing that is missing from this slide. One-way and two-way ANOVA. Let me undo this. Hey, sorry. Okay, and let's continue. Right, let's come back to here. So now we have this dependent variable. We have identified this dependent variable and independent variable, right? Performance, numerical, clothing, categorical. Can we use categorical performance, job performance? Okay, Pearson correlation definitely out, right? Because it's for continuous. Okay, chi-square for categorical. So if let's say this performance is in category, sorry, I'm using, because I'm using the keyboard in the lab. Let's say if this is also categorical, then it's possible to use chi-square, because chi-square is used to test categorical IV and BV, right? Independent two-sample t-test. Do you remember what is independent two-sample t-test? You have two groups and you give them different experiment. You have two groups, you give them two different experiment. That one is numerical. One of it must be numerical as well. One-way ANOVA just now, it must be more than 2 category. Right? But this one category only 2. So which is the most appropriate to use? Okay, let me give you a refresh on your, I think you are blur, right? Are you blur? Independent two-sample t-test. Independent two-sample t-test, you have 2 different group of people. You give them 2 different treatment. You still remember? 2 different treatment, and then you test their performance. That is for independent two-sample t-test. But you are not testing this group. You are not testing this group of people. You are not testing them, right? So independent two-sample t-test is not the answer. Pearson correlation out, independent two-sample t-test out. Now the leftover will be chi-square and one-way ANOVA. If you choose one-way ANOVA, means the clothing must be 3 category. Business clothing, casual clothing, and then maybe another one is what? Fancy clothing. Then, yes, possibly we can use one-way ANOVA. So performance can be categorical. If performance is categorical, we use categorical to test, then it is chi-square. 最怕就是这样子。哦，sorry。May I tap on the wrong keyboard again? How should I explain this? Well, you can only understand if you know the each of the what is it, the test, right? Okay, let's do something like this. Perhaps this can also help you. I think this is 学霸的方法是吗？你是这样子学吗？ Summarize all the tests. Okay. No, except for Cranberry Alpha. Cranberry Alpha is not an analysis test. Cranberry Alpha is only to test the reliability of the questionnaire. Yeah. So t-test. Oh, sorry. T-test, we have different t-tests. We have one sample t-test, right? One sample t-test. And then we have independent sample t-test. And then paired sample t-test. Okay. And then we have, what do we have? Correlation, regression, chi-square, and then one-way ANOVA, two-way ANOVA. And we try to give them some scenario and also the IV/DV and try to compare them. So let's say this is DV. Which one do you prefer, IV or DV come first? You prefer IV come first, and only DV, right? And then this is the scenario, example of scenario. For one sample t-test, this one. One sample t-test, you have only one group. You have only one group, yeah? You have only one group of sample. You are not comparing to other group. You are comparing one group with a standard. You give them a standard measurement and then you're comparing this group of screen size, this group of performance with the standard one. You have a standard one which is given to you already, a standard answer with a standard answer. We call it as answer, standard index. Okay, and then your IV, sorry, there's no so-called DV/IV here because you are comparing your standard, right? There is no so-called DV/IV here because you are comparing one group's index or measurement with a standard index. So this is not applicable. This is not applicable. Can you get it? And two sample t-test. Okay, we'll come back to here. Two sample t-test is that what is mean not applicable? Oh, we don't have IV/DV. Like if you take a look at here, what is the IV? What is the DV? Now your alternative hypothesis is saying mean screen size is different from 10 cm. Which one is IV? Which one is DV? There is no so-called IV/DV here, right? So not applicable. Okay, next. The ones independent two sample t-test. Independent two sample t-test, we have, for example, this alternative, we have sport performance increased by taking caffeine. So we have two different treatment, right? Treatment A and treatment B. Two different group with two different treatment. So sport performance is IV or DV? Sport performance is IV or DV? DV, yes, DV. So your dependent variable is numerical numbers, right? Sport performance. You're going to measure how fast you can run, right? Sport performance. So it could be numerical. Do you know what is categorical? What is numerical? You know, right? No. Numerical means when you give them measurement, the measurement, like for example, the sports performance, and if you fill in the sport performance, how fast you can run, how fast you can swing, 1.07 second minute, 1.05. This is a Malaysia competition that is currently organizing at Bukit Jalil. That's why I know their performance here. Because my niece is a state representative from Sarawak, 1.0575 like this. This is continuous or numerical in number. If you say, okay, what is your sport performance in categorical? It's a category A, category B, category C, swimmer, for example. Category A means those performance are fall from 1.07 to 1.075. Category B, 1.065 to 1.069. Of which category that you fall under, this is called category. But if you are measuring in numbers, then it is numerical. Now, can you understand the numerical and categorical? Can you get it? Cannot. Okay. All right. Now the treatment here can be categorical, right? Caffeine or non-caffeine. So this one can be categorical because the treatment that you take is either placebo or caffeine. Right? So can be categorical, and then dependent variable can be numerical because you need to compare the means. The means of two different sample means you're going to check this one. You're going to check this one. The mean. When you see the mean, you have to do numerical calculation. So DV is numerical. Okay, pair sample test. Let's try to look at it. This one, right? Okay, there is a difference between means of tire before and after changing the rubber material X and Y. So same group of people, same group of car, right? This one is comparing two groups mean. I'm just trying to figure out how we can compare and get answer from here. This might not be the best way to do it. You can go home and you can figure out by yourself what is the best way for you to really get everything clear, right? Okay, sample test. We have numeric as well, DV, because we want to measure the tire performance. Means of tire performance. Means this one is the average, average of your tire performance before and after you change to different rubber. So this one can be categorical again, but you are comparing one group's mean with different treatment. treatment here means we treat you differently. We give you different experiment. We give you different rubber. We give you different, this is also treatment. Give you different treatment. Placebo and caffeine, different treatment. This one with different treatment. This one also with different treatment, right? But we have two groups of people with different treatment and we compare two groups. But this one we have only one group. We give them the different treatment and see whether there is any difference. Okay. Then correlation, numeric. Regression, also numeric, right? Numeric. But then regression, we have many. IV. Right? Because we're doing something like X or Y. X equal to C plus. What is the formula? Is it the easiest formula also for confirm? Regression formula. Y equal, this is too difficult. Y equals to, because we have only E plus this one. Okay. Y equals to something something. Y is your, okay, dV. We use dV, okay. dV equals to IV plus, if you have IV1 plus IV2 plus IV3 plus a constant. And this one IV you have to times, what is that called? F is called what function? F1, F2, F3. We're going to come up with this formula. Okay, we will look at this. We will further explore this in your lab. In the lab, you're going to see this formula and get solved. Regression, correlation, regression. Let's see if we have any example. I think, yeah, you have. See? Your dV equivalent to the constant plus this F for this IV1, F2 for this IV2. So each IV will have their own F in front of here, which you get it from here. You get it from here. The result. That's a regression. Chi-square, categorical, right? Categorical and then categorical. One-way ANOVA, just now we have discussed this is numerical and this is categorical. Right? Categorical, but the, what is that? The category is more than 2. And then this two-way ANOVA, categorical, numerical, but this one you have many IV. Accidentally raise up your hands. Okay, let's please go back and digest and try to figure out. Let me give you the rest of the sample question. Can you take a screenshot of this? Screenshot this. Go back and try to figure out, and then we come back and discuss this again. Shall we? Take a picture of this, and then I think 2 more questions to go. Oh, these are from the past year question, yeah, multiple choice question. Oh, there is one more. Sorry, two more questions from the past year. I we shall come back and discuss the answer. Please go back and figure out this one. So you figure out this one and try to find a good way to identify or good way to try to figure out which analysis method you should use. Like for example, if you are given this case study, let's take a look. Let's compare the DV and the IV and the measurement categorical. Then we are going to what is it? Filter out what is not applicable from here. I think this is very helpful. If you can come up with a table, it can help you to quickly identify which analysis method that you should use. All right. That's all for today. Class rep, I need your cooperation to give me the attendance. For those who are in the lecture hall, this is the attendance code. 679,335. Okay, I have Ryan,